Why, hello there! Today we are going to be talking about the one, the only, the quadratic formula, prize tool of the mathematician and bane of Algebra 2 students everywhere. But fear not, intrepid viewers, for this is just a formula. All you have to do is plug in and evaluate, and you'll be able to get to your answers very easy, very quickly. Now what exactly are we looking for if we're using the quadratic formula? Why, we are looking for the x-intercepts, also known as zeros, also known as roots, and also known as solutions. If you are asked to find any one of those four things, then trust me, the quadratic formula is a very reliable way to go. And now let's get to the good stuff. That formula is seen right here. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You're probably going to want to have that memorized as soon as you possibly can. Rest assured, you're going to get plenty of practice with the quadratic formula. But as one last side note here before we get going, it has to be stated that if you ever are going to use the quadratic formula, please make sure that your equation is always set equal to 0 before you use the formula. You see, once again, the quadratic formula is used to find the x-intercepts of a parabola, and x-intercepts occur by definition at the points where y is equal to 0. So set your equation equal to 0 to make sure you get accurate results. And without further ado, why don't we go ahead and check out our first example. Here we are asked to find the x-intercepts of f of x when f of x is equal to x squared minus 9x plus 20. Now, like with any standard form quadratic equation question, the first thing we should do is identify what our a, b, and c are. And of course, a is the number in front of x squared, that's 1, b is the number in front of x, that's negative 9, and c is the constant at the end, that is 20. And once we have all these values, it's just a matter of plugging into the formula. X equals negative, the b value is negative 9, plus or minus the square root of b squared, that would be negative 9 squared, minus 4 times a is 1, and c is 20. Close up that radical. The denominator of our quadratic formula is going to be 2 times the value of a, or 2 times 1. Now, it's just a matter of evaluating. Negative is a positive, so we get positive 9. Negative 9 squared is 81. Negative 4 times 1 times 20 is negative 80. And then, of course, in the denominator, 2. And now we're going to evaluate underneath that radical. The 9 stays the same, but 81 minus 80 is 1. And we're going to put that all over 2. Had enough yet? I'm running out of room here. Let's start a new line. Of course, we are going to have in the top 9, square root of 1 is just 1 over 2. And now we have this very curious little plus and minus here. What that actually means is that we have to add the 1 to the 9 and we have to subtract it. So we got two different equations here. 9 plus 1 over 2. And then a second equation where instead of adding we are going to subtract our 1 all over 2. And then it's two equations here. 9 and 1 together is going to give us 10 over 2. And when you do 10 divided by 2, that's going to give you 5. Then we're going to do our other side here. 9 minus 1 is 8. 8 over 2 is 4. Ladies and gentlemen, we have two solutions here. X equals 5 and x equals 4. Now this is not a drill, folks. Anytime you're writing your answers, please be sure to put an x equals in front of it. That lets people know you understand exactly what you're looking for. And with that said, we can move on to our next example problem. So this time we are asked to find the roots of g of x, where g of x is equal to x squared plus 4x plus 4. Now remember, roots are the same thing as x-intercepts, are the same thing as zeros, are the same thing as solutions. So we're going to be doing exactly the same thing here, using the quadratic formula. First order of business as usual is to find our a, b, and c values. Here a is equal to 1, b is equal to the number in front of x, 4, and c once again is the constant, which is also equal to 4. And now we plug into our formula. Here we get x equals negative, our b value is 4, plus or minus the square root of b, 4, squared, minus 4, our a value is 1, and our c value is 4. Close that square root, and then in the bottom we are going to have 2 times our value of a is 1. Evaluating is going to get us a negative 4, plus or minus 4 squared is 16. Negative 4 times 4 is negative 16. Close the square root. 2 times 1 is 2. And in our next step, we are going to simplify underneath the radical. And of course, 16 minus 16 is going to give us 0. And if you're starting to scratch your head a little bit, good for you. Let's see what happens. Now, of course, as we'll see in a second here, we're going to take the square root of 0, which is 0, but we have to plus and minus it. And of course, if you plus or minus 0, it's the same thing, right? But that plus or minus still tells us we need to do two different equations, doesn't it? We have negative 4 plus the 0 over 2. And then we're going to have the negative 4 minus 0 over 2. Of course, we are going to get the same solutions here, but we may as well see this through to the end, right? Negative 4 plus 0 is negative 4, divided by 2 is negative 2. Negative 4 minus 0 is negative 4, over 2 is negative 2. We get the same answer here. So what does that mean for us? Well, it means we have one solution, folks, that is x equals negative 2. Graphically, this implies that we have only one x-intercept, or the parabola kind of bounces off the x-axis. It also tells us that our x-intercept is the same as our vertex. But as wonderful as it is to know that, that's not really the point of this video, is it? So why don't we go ahead and take a look at our last example here, shall we? In our final example, we are asked to find the zeros of h of x, where h of x is equal to negative 3x squared plus 2x minus 10. And if I say it once, I'll say it a million times, folks. Roots, zeros, solutions, and x-intercepts all mean the same thing. Our strategy here? Use the quadratic formula. So, without further ado, once again, find our a, b, and c values. This time a is negative 3, the number in front of x squared. B, the number in front of x is 2. And then c, our constant term, is negative 10. Plug into your formula. X is equal to negative b value is 2. Plus or minus the square root of b, that would be 2 squared, minus 4 times negative 3, our a value, times negative 10, our c value. All of this is going to be over 2 times our a value of negative 3. Let's go ahead and evaluate now. We are going to get negative 2, and then 2 squared is going to give us 4, and negative 4 times negative 3 times negative 10, that's negative 120. And then, of course, in our denominator, 2 times negative 3 is negative 6. Simplifying our radical here, we are going to get negative 2 plus or minus the square root of negative 116. How very interesting is that? Now, why, oh why, is this so interesting for us? Well, I don't know about you, but I can't think of any number that I can multiply times itself to get a negative answer. In other words, there is no such thing as the square root of a negative number, so this negative 116 right here doesn't actually exist. And this leads us to the somewhat depressing conclusion that there are, you ready for this? No, I can feel your anticipation. No solutions. Boy, you kinda can't help but feel like we just wasted a lot of time, huh? But hey, sometimes that happens. You get a negative square root, no solution. And that should do it for today, folks. I'm gonna scroll up to our f of x example because that's a little bit more routine. You'll see it more often than the other two cases. But regardless of the outcomes, the steps are always the same. Find a, b, and c, and then plug into x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Oh, it is like music to my ears. Alright, folks, thanks for coming, and we will see you next time.